Hello, this is question 2 from the 2013 MAT. Says here k is not equal to plus or minus 1. The function f, function of t, satisfies that identity for all values of t. By replacing t with 1 minus t, determine f of t. Okay, well, they've told us what to do, so let's do it, I suppose. Replace t with 1 minus t. So f 1 minus t minus kf, so 1 minus 1 minus t, which would be t, equals 1 minus t. So we've got that, and we want to find f of t. And let's write the other one underneath just so I can compare them, just see exactly what we've got. Okay, right, so we're nearly there then on this. We want to get rid of these f1 minus t. So if we multiply the top one by k, so put k, k, and k, then we can just add them up and we'll get just something in terms of f of t. Excellent. So we're going to have f of t minus k squared f of t equals 1 minus t times k plus t. So f of t will equal, so we'll have a 1 minus k squared. I just want to change this around because it's a function of t. I'd rather just have 1t rather than 1k on the numerator. So we've got a k, but then we've got a t minus kt. So we'd have a t 1 minus k plus k. So it just looks a little bit neater. You don't have to write it that way, but I think it just looks a little bit neater than having two t's there. Right, okay, that wasn't a bad starter. Consider the new identity, f of t minus f1 minus a t equals g of t. Okay, show that no function f satisfies that when g of t equals t. So when that equals t. So you want no function satisfying that. Right, so clearly they've led us part of the way there, because otherwise this wouldn't make any real sense. All right, yeah, it's the same thing. They set k equal to 1, having said that k can't be equal to 1. And why can't k equal be 1? Because we'll end up getting, well, we end up getting a mess over here. We end up getting k over 0. So that would mean f of t isn't even a function of t, and it's just some infinite value. So that doesn't make any sense. So, right, okay, so we can't just plug stuff into what we found out in the first part, which would have been the obvious thing to do. Show that no function f of t satisfies that when g of t equals t. So they've given us f t, this is second part, part A, minus f of 1 minus t equals t. So we've got that. We have to show that there can't be an f of t to satisfy that. Well, I suppose it's got to be usually the way in math. If you don't know what to do, which is the situation I'm in at the moment, do what you did in the previous bits of the question, because that's why they are the previous bits of the question. So let's replace t with 1 minus t and see what happens. So f of 1 minus t. All right, I can already see what's going to happen. Yeah, right, I probably should have seen that already, because they're just going to cancel out, aren't they? Yeah, this is what we've just done, but we don't have to do the k bit. Yeah, it's exactly the same as these two lines here, except k is equal to 1. So we're just going to add them up. Yeah. Okay, right. So add these two things up. Everything cancels on the left-hand side, but not on the right-hand side. We get 0 equals 1. So that's saying there are no solutions. Right, for f of t. Okay, right. Maybe I should have seen that a little bit quicker. But it highlights the point anyway. If you don't know what to do, look at the previous part of the question. What condition must the function g, function of t, satisfy for there to be a solution? Right, so if there is going to be a solution to this equation, then we need the right-hand side to add up to 0 as well. So we need that g of t plus g of 1 minus t needs to be equal to 0, in which case we're fine. Right, so that bit followed on quite nicely. Right, so things have been following a pattern. Find a solution f function of t to that equation when g of t is that. So when g function of t is 2t minus 1 cubed, so yeah, so if we do g of 1 minus t, we're going to get 2 minus 2t minus 1 cubed, which is 1 minus 2t cubed, which is minus g of t. Right, okay, so it does satisfy this, but I don't think that actually helps. That's kind of implied in the question, isn't it? Right, I'm going to need a new sheet for this because this looks like it's going to be quite hard work. Okay, so what am I trying to do? We've got g as a function of t is 2t minus 1 cubed. Am I going to want to expand that? Well, I can't think of what else I'm going to be doing at the moment, so it's really not obvious to me how I'm going to go about doing this. So anyway, let's expand it out. So we're going to get 2t all cubed, so that'd be 8t cubed. Then we're going to get 3 times 4 times t squared. So that would be, oh, and we got a minus 1. Yes, so let's not forget the minus 1, because we're going to have 2 lots of that, 1 lot of that. So we'll have a minus 4t squared times 3, so minus 12t squared. Then we're going to have a plus and a 3 and a 6. Then we're going to have minus 1. Okay, so that's g. And we need f. We need some function f that we're going to add to itself, having been transformed in some way. And that is then going to give us that cubic function. So a function plus a transformation of that function then gives us a cubic. So you think, well, f's going to be a cubic then. Kind of makes sense, doesn't it? So let's say f of t was t cubed plus bt squared plus ct plus d. So let's say that was f of t. And then say that we need f of 1 minus t. Oh my word, this is going to be unpleasant. So a 1 minus t cubed plus b 1 minus t squared plus c 1 minus t plus d. So we could compare coefficients. It doesn't look like much fun doing that at all. So here then we're going to get a, this is going to be 1, then we'll have minus 3t plus 3t squared minus t cubed. Then we'll have b of 1 minus 2t plus t squared plus the c 1 minus t plus d. Right, that just makes it a little bit easier to look at. So let's compare coefficients then for all of these. So t cubed, t squared, t to the 1, and t to the 0. And try and get some function. There's got to be a better way of doing it than this, I would imagine, but this is the only thing I've got available to me at the moment. So we're saying that 8 from our g of t is going to be equal to a from here minus the value, the t cubed coefficient here, which is minus a. So minus minus a. So 2a is 8. So a is equal to 4. Okay. T squared. So we're getting minus 12 from g has got to be equal to b minus, so we're going to get minus 3a, and then we're going to get minus b. Right, so that's just telling us that a is 4, so that hasn't helped. Right, hopefully the next ones are going to be more useful. So 6 is going to be c, and then we've got, so minus 3a, so plus 3a, and then minus 2b, so plus 2b, and then we've got, what we got here, we got a minus c, so a plus c. So we've got that 2c plus 2b, 2c plus 2b is 6 minus 12 is minus 6. Okay, right, wonderful. And then for the last one then, well, let's just write that out as I can just say c plus b is minus 3. So we've still got a chance of getting just one set of values then. So t0, what we got, minus 1 is d minus c. Oh, we've got more than that, and we've got all these a's, yeah. Okay, fine, start from the other end then. Minus c, minus d, minus b, minus a. So the d's cancel. So that gives us that a plus b plus c is equal to 1. Okay, a is 4. So that gives us that b plus c is minus 3. Right, so we just repeated what we got there. So what is that telling us then? So that's what that's telling us. We've got a load of solutions on this. So we can have, out of this is saying we can have any d, because d just doesn't come into this. We have to have that a is equal to 4. And then we need that b plus c is equal to minus 3. Right. So let's then say we need to find a solution. So let's say f of t then, we'll say it's 4t cubed. We have to have that. Let's say that d is 0, because that just makes it easy. Let's make c 0, which means that b would be minus 3t squared. That would do, wouldn't it? I mean, you can have any combination that satisfy those criteria. I don't like that question. It makes me think I've done it wrong. It does make me think I've done it wrong. I mean, I suppose we can double check this bit. It was so long-winded. I'm not so fussed about the answer. I mean, maybe I've got the answer wrong, but the method just seems really rubbish. But if I had that, f of 1 minus t would be equal to 4, 1 minus t. Well, it's all of this thing, isn't it? I don't need to write out all of that because I'm just going to be expanding this out. So I'm saying that a is equal to 4, b is equal to minus 3, and then I'm ignoring all of that. I'd have been better off setting c equal to minus 3, probably. It would have been a little bit simpler. So I'd end up getting this for f of t, and then I take off all of this. I'm not sure I can be bothered to do this, really. I mean, it might be worth it, I suppose. And we've got to end up getting this. So f of 1 minus t is going to be, what have we got then? I'll just go through all the terms. We've got a 4 minus 12t plus 12t squared minus 4t cubed, then minus 3, then plus 6t, and then minus 3t squared. Okay, so we've got all of that. I think that's what it comes out with, doesn't it? Yep. And then we've got to add these things together and get that. Well, let's just get rid of some of the bits in here anyway. We've got, so a 4 and a minus 3 become a 1. How many t's have we got? We got a minus 12 plus a 6. So we've got a minus 6t. That's dealt with those. The t squareds, we're going to have 9 of them by the look of it. 9t squared. And then we've got minus 4t cubed. So we have to do this thing here minus this. So for our t cubes, we've got a 4 minus minus 4 gives us our 8. For our t squareds, we've got a minus 3 minus 9 gives us our minus 12. And then we've got the minus 6 becomes a plus 6 and the 1 becomes a minus 1. So it does work, but it's just a bit of a sucky sort of question, this one. If you've got a better way of doing it than this, which is quite possible, then please let me know. I don't really like it when you're just sort of slogging through stuff like this, but sometimes maths is slogging through stuff like that. So that's the best I've got to offer when it comes to this question.